Hello, let's solve another question, the maximum subarray problem. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. Contiguous here just means a group of numbers or indices that are grouped together. It can be any group like this. So let's look at this example where we have these numbers -2, 1, -3, and so on. We need to find a subarray that has the maximum sum, and the numbers can be either negative, 0, or positive. So we need to be careful about that. The first thought would be to iterate over the array starting at each index and keep track of the maximum sum. And we can do this. So let's say we start from index 0. We keep track of the sum as we iterate over the list. So initially it would be -2, and then -1, -4, 0, 0 -1, which is -1, and then 1, 2, -3, and then 1. So these are the different sums you would get when you started from index 0 and end at different indices in the list. You can see that the maximum we got here was 2. Similarly, we can start from index 1 and go through the entire list. So here we would have the sums as follows: 1, -2, 2, 1, 3, 4, -1, and 3. Here we see that the maximum sum we got when starting at index 1 was 4. In this manner, we could do this for each index in the list, and we would have arrived at 4, -1, 2, and 1, which gives a sum of 6, which is the largest sum. So this should work, and the way we would implement this is have a nested loop where we first iterate from the basic list, and then we iterate from that index to the end of the list. While this solution would work, it would have a time complexity of big O of n squared since we have a nested loop. Which is not ideal, and there should be a better way to do this. This can be improved by using a smarter approach where we iterate over the list and decide whether to keep the current sum or start with a new sum. This can be done using Cadane's algorithm. Let me explain how it works. As you iterate, you have a continuous running sum and a new number. If adding the new number to the current sum makes the sum lesser than the new number itself, then we might as well start with the new number, right? The previous sum is not helping. It's probably easier if we run through an example and see how this would work. Let's say we have index for this list, and we have current sum. So initially we start with index 0, and the current sum would be -2. Next, we're coming across a new number at index 1, which is 1. So here we need to make a decision when we encounter a new number. You have the current sum of -2 and the new number being 1. So if you add them, you would have -2 plus 1 equal to -1. And the new number itself is equal to 1. So when we are adding the previous sum to the new number, we're getting -1, which is lesser than the number itself, which means the previous sum is not being helpful to find the maximum. So we can update current sum to be the maximum of these two, which is the maximum of -1 and 1, which is 1. So just update it to 1. Similarly, when we face -3, -3 plus 1 is equal to -2, or the new number is -3. So -2 is actually better than -3, so we can add that to the previous sum as it's helping increase the sum in general. So we have -2. Now we do -2 plus 4, which is 2. or the new number itself is 4. So you have -2 and 4. So you would rather take the new number itself because it's higher. So you go with 4. Next you have 4 minus 1, which is 3 or -1. 3 is better. So you go with the sum. So you update the current sum at index 4 to be 3. Next you have 3 plus 2, 5 or 2. Again, 5 is better. So you include the sum, which means at index 5, you take the sum to be 5. And then you have 6 or the number itself, which is 1. You would go with 6 again. Then you have -5. So the sum would be 6 minus 5, which is 1, or the number itself, which is -5. And 1 is better. Finally, you have 4. So the sum would be 5, and the number itself would be 4. In this case, you would take 5. So at index 8, you have 5. So as you see, we've computed the maximum sums when you end at each index. So if you look through this entire list, we have the maximum sum that you get when you end at a certain index, regardless of where you started. So if you take the maximum of this, you have 6, which is our result. It's quite a cool algorithm, and once you understand how it works by running through an example, it makes things a lot easier. The basic principle behind it is that at each step, you're deciding whether to include the new number or not. So let's say you have a certain current sum, and you have a new number. So you have two options whenever you encounter it. If you add both of them and you have a result that is greater than the new number itself, then you would take the result. If not, just take the new number because the previous sum is not helping. Let's write some pseudocode to see how we can implement this. So let's initialize our result and current sum to be the first number. So we can have result equal to nums of 0, and we can also have current sum equal to nums of 0. Then we want to iterate over the list. So we do for num in nums. And we can just iterate from the first index. And in Python, you could just do this, but this is pseudocode, so just trying to get an idea of how the solution would be. And we have two situations here. If current sum plus number is greater than the new number, then the current sum will be equal to the sum, which means you're including the number. In the other situation, the previous sum is not helpful. So you would just put current sum equal to the number. Finally, we also need to update the result at each step, which means as we keep computing each of these, we want to make sure that the result always has the maximum value. So result would just be the max of result, comma, current sum. And finally, we can just return result. So this algorithm greatly simplifies what seems to be a tricky problem and lets us implement the solution in an optimal manner. If you think about it, we're just iterating over the list once, which means the time complexity would be big of n, n being the length of the list. And we just have two variables result in current sum which we're using. So the space complexity would be big of 1, which feels like a good solution. All right, let's go ahead and implement the solution on Leetcode. We have a function max subarray with the input nums, which is the list of input numbers. Let's initialize result to be the first number as discussed. We can have the current sum as well to be equal to the first number. One edge case we need to handle when nums is empty or null, we can just return 0. Let's iterate over the list now. We can use this syntax in Python to slice or use a certain section of the list, in this case from index 1 till the end of the list. We now want to check if the current sum plus number is greater than the number. In this case, it means the sum so far is helpful in increasing the contiguous sum, which means we can update current sum to include the number. The else case would mean that the number itself is better than including the sum so far. So let's update current sum to the number. At each step of these iterations, we want to make sure that result is updated with the maximum value that we've encountered so far. So it'll just be max of result and the current sum. After the entire loop is complete, we now know that result holds the maximum subarray and can just return that. Let's go ahead and run this code to see if it works. It does work for this example. One more thing to consider here is that this kind of syntax is generally easier to understand and explain, so it's good to do it. But an alternative way to do this would just be max of current sum plus number or the number itself. It's kind of achieving the same thing where we are deciding if the current sum plus number is greater than the number and then assigning it accordingly. This should have the same effect. Let's go ahead and submit the solution to see if it works for all possible inputs. Looks like it's working as expected, and the space complexity is big of 1 because we're just using a couple of variables, and the time complexity would be big of n because we're iterating over the entire list. Thank you.